So this video is going to be on FRQ 2009 question 4, which is essentially on area between the curves and value of cross sections. So the first part states that let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared, as shown in the figure above. And part A is going to ask, find the area of R. So this is essentially just going to be area between curves. So first we want to find the area between the curve using the top function minus the bottom function. So that's going to be using the formula from A to B, top minus bottom, dx. And using the graph, we can plug numbers into this formula. So the integral from 0 to 2, and the top function, as you can see, is going to be 2x, and then the bottom is going to be x squared dx. And then the next thing you're going to want to do is find the antiderivative. So you can do this by adding the degree plus 1. So that's going to be, and then you divide by it. So it's going to be 2 over 2 x squared minus 1/3 x cubed from 0 to 2, which is going to simplify to x squared minus 1/3 x cubed from 2 to 0. And then we can just evaluate it by plugging in 2 and 0. So that's going to end up giving you 4/3. And you should note that your answer should always be positive when finding the area between curves. So if we look at the answers, you can see that you'll receive 1 point for writing the integrand, 1 point for the antiderivative, and 1 point for the answer. So for the next part, part B, it states that the region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has area A of x equals sine of pi over 2x. Find the volume of the solid. So essentially in this problem, they're already giving you the area of the cross-section, so you don't have to find a formula for it, so we can essentially already just plug it into our integral. So the volume is going to equal the integral from 0 to 2, and then we can just use this formula, sine of pi over 2 x dx. And now you're just going to want to evaluate it, but in order to find the antiderivative, you're going to have to use u substitution. So I'm going to set u equals to pi over 2 x, and then I'm going to find the derivative, so d of u equals pi over 2 d of x, and then I'm going to isolate d of x, so d of x is going to equal 2 over pi d of u. And then what you can do with this is plug it back into your integral. So I'm going to move the coefficient, move the 2 over pi to the outside to make it easier to work with. So 2 over pi, integral from 0 to 2, sine of u substitution, and d of u. And then in this format, then we can find the antiderivative. So the antiderivative of sine is negative cosine, so the antiderivative is going to end up being negative 2 over pi cosine pi over 2x from 0 to 2. And then after this, you can just evaluate the integral by plugging into f of 2 minus f of 0. And if you do this with a calculator, you're going to end up getting 4 over pi. And if we look at our answer, you will receive 1 point for the integrand, 1 point for the antiderivative, and 1 point for the answer, which we all have here. Great. Moving on to the final part, part C, which states that another solid has the same base R. For this solid, the cross-sections perpendicular to the y-axis are squares. Write, but do not evaluate an integral expression for the volume of the solid. So since it says it's perpendicular to the y-axis, you really have to notice that. It's a key part of it. You have to convert the equations in terms of x. So you see these equations and you convert them. So which will end up being y over 2 equals x and root y equals x. We then have to derive the formula of a cross section for a square since we know the base is s. You could have this memorized, but you should be able to derive it on the test. So with our base s, you know that the formula for the area of a square is just like side times side, so that's just going to end up being s squared. With this formula, we can then create our integral. So our integral is going to be from 0 to 4 and not 0 to 2 because it's in terms of x. So the y-axis, perpendicular to the y-axis. So from 0 to 4. And then we can do the outer function minus the inner function. So this is going to be the outer function now, root y minus y over 2. So it's going to be root y minus y over 2 squared dy. And that's our answer. And if you look, at the answer, you'll receive 2 points for the integrand and 1 point for limits. And you should look in the description. I have some helpful worksheets and another video if you need any more help with this concept. And that's FRQ 2009 number 4. I hope this was helpful.